Gusto kong makita yung mga audience. Okay, good morning everybody. Magandang umaga po sa inyo lahat, no? Good morning, good evening, no? Good afternoon, no? Whatever time, no? You are listening, no? All over the globe, no? Because of course we are on Facebook, no? So any people may watch our live, no, lecture, no, about electrical engineering, no. This is what we call the Study Electrical Engineering the Filipino Way, no. So my name is Engineer Reggie Marinay. I'm an electrical engineer. Okay, so I am the president and one of the owner of one of the electrical engineering review center here in our country, the Philippines, no. So the name of our review center is Marinay's Powerhouse Team Review and Training Center, no. So we've been giving free lectures since June 17 of this year, no. Okay, so this is a part of our advocacy, no, giving lectures to our fellow kawerpa, no. You know the meaning of kawerpa? Because yesterday I saw some comment. There are some Indian nationals, no, giving their comment, no, and asking something to me, no. So because I post my lecture on the Facebook, no, there are some foreigner giving comment to my lectures, no, and they're interested to listen, no. That is why I have to make this the language that many people all over the globe will understand, no. Although I have to apologize, no, because I'm a Filipino, no. I am our language in our country. There are so many languages or dialects in our country. So many dialects and languages, no. But one of the popular nowadays, the modern Filipino language, you know, we call this as the Taglish. Taglish. What is a Taglish? This is a combination of Tagalog, and English, no? This is actually, no? This is the reality in our country, no? So we speak in Taglish, no? Taglish. This is a combination of Tagalog and English language. Okay, wherein majority of the Filipinos speak this language, no? It's quite hard for us to speak purely in Tagalog, no? Because there are really terms that we really have to make it in English. But do not worry to our non-Filipino audience or our non-Filipino friends listening or viewing our Facebook live right now, no? We'll try to make it, I'll try to make it to speak in English, the lecture, but I have an idea. I think this is one of the best idea, a different idea, a unique idea that after discussing this in English, I will make a little translation in our language so that I can cater more to our Filipino students, no? But do not worry. You will understand this because I will discuss this first in English, no? I'm sorry that I am not that fluent in speaking the language, no? The English language, no? Because in our country, if you are an engineer, many people said that engineer are not, they call this, are not that fluent in English, no? Just like in the other courses, mass communication, tourism, they speak well, no? Our fellow men, no? Here in our country, no? If their course is tourism, mass communication, journalism, broadcasting, they speak well in English, no? But in our country, if you're an engineer, you don't speak English well. So that's why I have to apologize with you guys, no? There is a saying here in our country, if you are good in math, you're not good in English. If you are good in English, you're not good in mathematics. That's the saying in our country. Okay, so let us start now our topic for today. Again, for our late tuner, good morning everybody for our topic for today. No, this is our topic for today. Okay, again, I will apologize, no, especially to our American viewer if there are, no, maybe they can watch this, no, all over and all over again in the YouTube, no. It's really possible that Americans may watch this lecture video, no. British, no, may watch because they are really fluent in speaking the language, no. Uh, I'm sorry that I'm just no, I don't have to be sorry for this. So I am a Filipino. It's just that I have to make some conversion in my mind. You know, it's really hard for me before I deliver the the language. So you know, there is what you call a manipulation in my brain. No? Unlike if I will speak in Tagalog, I can speak it directly, no, without any conversion. So just like a CPU, so I have to convert it in my mind. No? So I have to apologize to, especially to Americans and Europeans who speak English fluently. No, but what I can dare with you, all of you, all people in the world, I can dare with you only one thing: the way of teaching. That's the only thing I have. No? That's the only thing. I may not speak pure English or English fluently, but I'll try my best for you to understand, no? Well, my English is just a grade 1 English, no? You know that it's a lower English, no, that everybody may understand, no? Okay? Although in our country, we started learning English, no, before grade 1. So there is a preparatory grade, kindergarten, no? And then grade 1 from elementary up to college, up to masteral studies. English is always, no, being used by Filipinos, no? So again, to our fellow men who are Americans and Europeans or even British, no, who really speak English well, no? So I hope you comprehend. Okay. So because there are just some manipulation in my brain before I deliver my talk. It's quite hard. It's quite hard because this is just my second day to speak the language. On a majority of my lecture will be in English, and we have to put this in the YouTube that enclose in parentheses that English, no? Okay? Because there are some, I have some Indian friends. They really love electrical engineering, no? They want an English translation, no? Partner, did you saw that? There is somebody from India requesting, are there any English translation? I think I can easily understand the way you teach. But I hope you have an English translation. So, your wish is my command, my friend. So, this is it. Okay? Okay. So, let us start now our discussion. We only have one topic. This is still electrical principles. This is a very long studies of electrical engineering. Study electrical engineering the Filipino way. So, we have Ohm's law. That is the only topic for today. Oh, sir, the Filipino student would say, Ohm's law, during our college, is just around 5 to 10 minutes discussed by my professor. Why is that? The whole seminar will just be talking about Ohm's law. But wait, no? This is Ohm's law in focus. Maybe you will hear somebody discussing Ohm's law for around more than 2 hours, maybe. Around 2 hours. You will hear or see somebody giving lecture, a very long lecture about Ohm's law. I think I did not see anything from YouTube that uploaded Ohm's law for 2 hours. So, I'll show this to you now, guys, no? Okay. Ohm's law in focus by Kuya Reg, no? By the way, Kuya Reg, Kuya means a big brother, no, in our country. Reg is my name, no? So to our non-Filipino friend, no, just call me Kuya Reg or Reg, okay? So my name is Engineer Reggie or Reginaldo Marinay. I am a registered electrical engineer, no? And also I have one profession. I'm also a master plumber, no? A licensed master plumber. Okay. So let's go here. We are going to study Ohm's law to the deepest we know, no? To the deepest we know, okay? To the most detailed we know. To the broadest and deepest style of giving a lecture, no? Okay, so we have Ohm's law. Okay, please focus on our PowerPoint. According to Ohm's law, at steady state condition, the voltage across the resistor is directly proportional to the current flowing through it with the temperature remaining constant. Huh? We have this formula, okay? The voltage V, okay, please focus this, partner. The voltage V is equal to IR. Huh? Okay? That is our Ohm's law. No? The voltage V is equal to IR. No? Where V is the voltage applied in volts, I is the current drawn in amperes, R is the resistance in ohms. No? So, V is the voltage applied in volts, I is the current. No? What's this in our country? Filipino audience, what's this? What's this, Billy? What is I?
Current, sir.
Current. Okay, current. Okay, Billy. Current. I is current. 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 I is current. Current. It's like this one, Billy. How you pronounce it? Current. No, it's not current. No, it should be current. Current. No, it should be current. No. Okay, everybody. Current.
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 Okay. Okay, there is a more profound way of pronouncing it, no? It's current. Just say, class, current.
Current.
Current. Okay.
Current.
So that we may please our British audience or our American audience, no? So it is not current, it is current, no? It is current, no? Okay. From time to time, I'll be teaching you some pronunciation. Okay? Some pronunciation. Okay. Let's go over there on the board. No? So we have a triangle. We have a triangle. Please focus here. Okay. Take a look at this triangle. So this is our voltage V. This is our current I. This is our current R. V is the voltage in volts. I is the current in R. I is the current in amperes. R is the resistance in ohms. Okay? Now, if we are to get our voltage V, okay, let us put my hand here. Not our hand, my hand. Okay? Okay, so I will put my hand here. So, we have here our V. What you will see here is just a VI, right? Please focus here. Okay, that is equal to VI. IR. So, V is equal to IR. No? Okay? So, beer. Beer. No? You know beer? Okay. Don't drink beer. Okay. So, what is R? What is the resistance R? Please take a look here. What is our resistance R? What will be left here is our voltage and current. This is our voltage and current. Billy, what is our V? Billy?
Voltage, sir.
Will you show Billy on the screen so that the international audience will see Billy? What is V, Billy?
Voltage, sir.
Voltage. Okay. Voltage. Voltage. Do not pronounce it as voltage, Billy. Okay? Pronounce this as voltage. Voltage.
Voltage.
Okay? Sino yun? Who's that? Okay. Okay, Billy. You pronounce it voltage.
Voltage.
Ganun pa rin eh. Okay, Billy. Voltage. Voltage.
Voltage.
Ganun pa rin. Voltage.
Voltage.
Voltage. Do not say acknowledgement. Just say acknowledgement.
Voltage.
Okay, just say, Billy, acknowledgement.
Acknowledgement.
Acknowledgement. Okay. So, do not speak here. Do not pronounce this as voltage. Pronounce this as voltage. You know the Kirchhoff's law? I saw from YouTube, no, I watched from YouTube, one of the pronunciation is Kirchhoff's law. No? Okay? That is our next topic, the Kirchhoff's law. Okay. So, if we are to find the resistance in ohms, what will be left is V over I. No? So, this is V over I. That is the voltage over resistance. That is our voltage over current is our resistance. Okay? Voltage over current is our resistance. Now, if we are to find our current, okay, let us put, I will put my hand here. So you will see here that is voltage over resistance. No? So we have V over R. So this is voltage over resistance. No? Voltage over resistance. Okay? So, from this equation, we can state Ohm's law from this definition. Please focus our camera here. It's better to state this as this one. No? Ohm's law states that the current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance. No? What do we mean? If we increase the voltage, this is the voltage, this is the current. If we increase the voltage, the current will also increase. If we decrease the voltage, the current will also decrease. Okay? The current will also decrease. Okay. So if we increase the voltage, no? Okay. If we increase the voltage, the current also increases. If we decrease the voltage, the current also decreases. No? So, we have proven that in an experiment, no? In my school, in the university, no? At University of the East Caloocan, we have an experiment, no? In our direct current circuit class entitled Ohm's law. This is the circuit. There is a voltage source here. There is an ammeter here. Okay. Then there is a load here. Load resistance. A variable resistance. This is a variable resistance. An arrow here signifies a variable resistance. And then this voltage is a variable source. Actually, it came from a variable AC source. It came from a variable AC source. Then we rectified that, no, using the bridge type rectifier. So we may adjust the value of the DC source here. Okay, so this is the ammeter, and there is a voltmeter here. This is the voltmeter. So you will see here, there is a voltage V. Okay, so we have a voltmeter V here to measure the voltage. We have our current in amperes. Then we have our resistance. I remember we fixed the value of the resistance to 1 ohm. 1 ohm. There are 10 trials. So this is the trial on that particular experiment. 1, 2, 3, 4, up to 10 trial. Okay, so there is a voltage here, there is a current, and the resistance is fixed to be 1 ohm. No, 1 ohm. Up to the 10th trial, it is fixed at 1 ohm. As we increase the voltage from 10 volts, let's say the first trial is 10 volts, 20, 30, 40 volts, up to 100 volts. As we increase by the use of the variable DC source here, as we increase the voltage, the current also increases. Okay, for the first trial, let us adjust from 0 to 10 volts. Approximately, the reading here is 10 amperes. Okay, let us increase the voltage to 20 volts. So, 20 amperes to 30, 30, then 40, up to 100 amperes. So, this will become 100 ampere. Well, that's correct, no? Because we have V that's equal to IR, no? Considering we have 100 volts, that's equal to 100 times 1 ohm, no? Okay, so that will be equal. They are equal, no? So we have here 100 ampere multiplied by 1 ohm resistance. That will give us 100 volts, no? So that is 100 volts. Okay? So we have, if we are to look to get the value for the current, so our current here simply equal to the voltage over resistance. Let's go on trial 3 here. So we have 30 volts. 30 volts. Then divided by 30 ampere. 30 ampere. To get our resistance, I mean. No? Resistance is voltage over current. So therefore, we'll be having here 1 ohm. No? 1 ohm as our resistance. Because 30 over 30 is 1 ohm. No? So, as we increase the voltage, the current also increases. As we decrease from 100 volts, 90, 80 to 10, the current also decreases. Take a look at the relationship to the resistance. Okay. We have here the voltage, then we have the resistance. There. For example, we have here, take a look here, on this trial. Let us consider at least 3 trials. Let us make this as 1 ohm, this is 2 ohms. And this is 4 ohms. Let's say this is 4 ohms. Okay, so this is the value. Huh? And then let us fix the value of the voltage to 100 volts. Okay? Let us fix the value of the voltage to 100 volts. This is 100, 100, and 100. Okay, the reading, if we are to fix our voltage source, and then we'll make some adjustment to our loading rheostat, no? Our adjustable resistor. We will make some adjustment here. No? Okay. So, I remember one of the adjustable resistor we use is the loading rheostat. So, will you close up this figure? This is a resistive element here. Okay. Then this is the pointer. Let's say this is 0%. This is 100%. This is 50%. Okay. Then 25%. And this is the 75%. Let us have our experiment here. So, okay. So, this is the pointer. Okay. So, this is the pointer. And then, we have here one terminal, and then we have the other terminal. No? Okay? So, there's no polarity here in our loading rheostat. No? So, let's say this point is this point. Okay? And this point, no? Let's say this is point A and this is point B. This is point A, and then this is our point B. So that if we put our pointer here, this is we are on approximately 75% of the resistance. Let's say if this is 100 ohm, you are in 75 ohm. If we are to put here, we are on 25 ohm, let's say, no? Okay? So, if we are to fix our voltage to 100 volts, huh? Our voltage to 100 volts. What will be our current here? No? Okay, so 100 over 1. So, what is the formula for the current? Our I simply equal to V over R. Okay, so we have 100, okay, divided by 1. So, we have 100 also. We have 100 divided by 2. So, we have 50. So, we have here, what? 100 divided by 4. So, we have 25. Okay? What relationship we can have, no, in this experiment? As we increase the resistance, take a look here. As we increase the resistance, okay, from 1, 2 to 4, what happened to current? 100, 50, 25. It decreases. Okay, please take note of this relation because this is very important. We will discuss this further, this relation. It's very important, especially in the licensure exam and in your college examination. You should know how to make equation. No, you should differentiate the directly proportional to inversely proportional. Again, let's go over here. If we increase the voltage, the current increases. If we decrease the voltage, the current also decreases. Therefore, they are directly proportional. What about now for the current? What happened here is the resistance increases, the current decreases. Okay? What if we decrease the resistance? Let's say from 2 to 4 to 1. What happened to current? It increases. Therefore, that is what we call inversely proportional. Huh? Inversely proportional. Mathematically, how do we put that in symbol? So, what is inversely proportional? Okay, so, is this one? This is the current. This is the resistance. Is this the sign? Yes or no? If we are in inversely proportional, we have this here, just like this one. Is it like this one? Voltage is directly proportional to the current. My student said, "Sir, this is the picture of directly proportional." So, the same as this. So, we have to, since this is inversely proportional, let us reverse this. My student would say that. Okay? Is that inversely proportional? Therefore, you put the eye here and this is the teeth of the fish. That is a fish. No? So, the inversely proportional is this. The current is an inverse relation. mathematically, you should have this equation. That is an inverse proportion. Okay, take a look at the equation here. If, this is the shortcut, if the equation or the variable is on the numerator, okay, that is directly proportional. This is the current. Since this is the voltage V is on the numerator, ibig sabihin, nasa taas siya, meaning it is directly proportional. If the variable is the denominator, nasa baba, meaning it is inversely proportional. Okay? Again, the voltage is directly proportional to the current, no? And the current is inversely proportional to the resistance. Did you get that? Did you get that, Shelu? Can I hear your voice?
Yes po.
Okay, yes po. Okay. So, we are finished with my introduction. Okay. That is just an introduction. No, it's not an introduction. This is where we will go. This is just like a movie that we just started at the near end. No, diyan tayo papunta. Okay? This is our target. No? Why is that, sir? It will take around 2 hours to study Ohm's law. That's already finished. Because we have to define each of these. The current, the voltage, and the resistance. And if I still have time, I have bonus to everybody. This is a so many questions to many of my students. You see the picture? Is this an eagle? Okay. An eagle signifies the king together with the lion. No? Okay? You know, I am a lion lover. No? I have lion here on my side. Will you show to them my lion? This lion? I have a collection of lion. No? And also in my, there, no? In my bookshelves. I have around more than 30 lions, no? Okay. So, this is an eagle. How I wish that there is lion here. Okay. Why is that the bird they don't get electrocuted in the transmission line? And that is my bonus to everybody if I still have time, no? If there will be no more time, so that's sorry, time is up. Okay? So, do you want me to discuss this, everybody? So many students asking me that. Billy, do you want my answer for this question? Billy?
Yes, sir.
Okay. Why is that any bird don't die since this is a high voltage and the current flowing here is enough for them to die? No? Okay? Don't you know that 0.2 ampere human being may die? But take a look at the YouTube. There are linemen having his repair, no, via helicopter, making some repair of the transmission high voltage lines. But they don't die. No? That Chinese national, no, lineman is making some repair. I'm watching it in YouTube. Why is that bird don't die? That is my bonus lecture to everybody. Okay. Let's go here. Electric circuit. It is a collection of electrical elements interconnected in some specific way through which electric current flows or it is intended to flow. Okay. If we mean electric circuit, it is the path where the electric current flows. Oh, by the way, did I discuss this last time or yesterday? I do not believe with the word the current flow that is being used all over the globe. But sorry to say this, I don't believe with that term. That is a wrong term. It is just like why the yellow pinfish is color orange. It should be orange pin fish. Why is that? Okay, Reggie, you erased the blackboard. Mom, this is not black. This is green board. Right? Why is it called a whiteboard? Because it is white. My grandma would said, "Grandson, do you want me to cook the egg? What do you want? A beaten egg or the yolk or the what do you call the he called that the yellow part as the red one, yung pula. Pula, ano gusto mo ba buo yung pula?" Sabi ko pula, eh lola, yellow 'yan, no? Ba't ba ako napunta doon? Ano ba yung what did I say here? No? What did I say? I forgot. What did I say, Shelu? Okay. Very good, partner. Thank you for reminding me. Why is that I don't believe with the word current flow? We have no choice. That is being used all over the globe. No? But we have no choice. But for me, I do not believe I'll be speaking here on an international audience. Why is that I don't believe with the word current flow? Why? Maybe I will discuss this one later because I have to define it. Kailangan ilatag ko munang mabuti bawat ano sa inyo, no? Later, I will answer that. Okay? Once we go in the current. Okay, let's go here. If we mean electric circuit, there is voltage, there is current flow. Where is the resistance? The resistance of the incandescent bulb here. There is a resistance here. There is a switch. I saw an electrical engineering book, but I do not believe with that book. Oh, sir, are you crazy? You are letting the book, you are saying that that is wrong. I'm not saying the whole book is wrong. For me, there is just a bit short. Ano ba yung kulang? May kulang eh, no? It's not complete. He said, the author would say, there are 4 major components of an electric circuit. What are the 4 major components of an electric circuit? He said, these are the 4 major components. Okay? What are the 4 major components? No? Will you recite? Will you recite, Joshua? What are the 4 major components? What do you see in our circuit here? There is what? There is what? What are the 4 major components you see here? Will you unmute?
Conductor.
Hello?
Battery.
Battery, what is a battery? It is, generally, it is a
Source.
source. Okay, what else, Joshua? Will you show Joshua in in our audience?
Load.
Is it highlighted already in the Facebook? Okay, so that our audience will see that there are a live audience. What, Joshua? A load. Okay, there is
There's a load.
load. Okay. What else?
Conductor wire.
And
There is a conductor. Okay.
yes, conductor. And switch.
A switch. Okay. The book stop here. But for me, that's wrong. But for me, that's wrong. Why is it wrong, sir? It is already found here. For me, pagkakulang, mali yun. Kulang eh. Di ba? Yung plus nga, maging minus, mali na eh. Mali ka na sa exam eh. Just like cooking. No? If you are to make or to cook one of our best dishes, adobo. No? Let's say, adobong manok. No? It is a, what we call this one? What is the adobong manok in English? Chelo. I forgot. I don't know. The chicken adobo. No? It is a chicken that has a sauce, that has a soy sauce, no? One of the best Filipino dishes. If you don't have a soy sauce, it is not adobo. Kulang yun. Yung sinigang, pag wala siyang paasim, hindi masarap. Okay. There is missing here. There is missing here. I'm sorry for our non-Filipino viewers, no? From time to time, I just speak a bit Tagalog. Okay? Okay. So please bear with us, no? Just stay there, please. So, there is a source, there is a load, there is conductor, there is switch. There is missing here. What is missing here? Anybody, you recite. Anybody. What is missing in our circuit? What is missing? Anybody would like to recite? This is a Zoom class. This is a classroom format. No? So this make it different with some direct lecture on the YouTube. No? This is an interactive classroom discussion. What is missing in this ingredient? Anybody? Do you think it's already complete for a practical electric circuit? Do you think it is already complete? What is missing here? Yes, Sir Garcia, do you have any idea? Mr. Garcia? What do you think is missing here? Anong kulang dyan, sir?
Man, operator.
The man is not part of the electric circuit. Sorry. Billy, are you listening to me? Billy? Anybody who would like to answer? There is missing here. Okay, I'll give you a clue. Once I give you the clue, you can easily answer. The first letter is P.
Electrons flowing, sir.
What is P? Come on, guys. Jonel, what is missing here in our...
Electrons flowing.
Electron is already there is a source here.
Okay.
No, it's not electron. It's not electron.
Power.
Power? We already have the source. Oh, come on.
Potential difference.
Oh, that's already the source. Anybody? Still, you can't answer this? Oh, from our foreign friends. Of course, they cannot answer because they are not in our Zoom class. No? So, we only have our Filipino audience here. Filipino cannot answer this? Oh, come on. Shelo, what's the answer here? What is P? Okay, another idea. This is the most important part of the circuit. If the circuit is already connected to the source. Ha? Ayun naman, tingnan nyo lang yung building. Take a look at the building. What's the most important there? If the building is already constructed.
Protective device.
Yes, Marlo Aquino. Yes, Marlo, ano sagot mo?
Protective device, sir. Protective
What?
device.
Pakilakas, pakilakas. Speak louder. Mahina. May problema sa signal. Will you speak louder? Nawala naman siya. Your answer is protective device? That's what I've heard before. Yes or no? Wala, na-stack up na yung signal niya.
Yes.
Okay, anyway. The answer is protection or protective device. That's correct. In general, that is protection. Do not forget this. Any electric circuit must have this. Okay? Do not forget this. If I am to make a book, I will put here a circuit breaker or a fuse. That completes the electric circuit. Okay. Let us now break down each component. You already saw the whole Ohm's law. But let us go deeper. Let's go to the detail. What is electrical potential? The ability of a charged body to do work on charged particles, such as electrons. So if we mean electrical potential, there is a work on the charged body. There is work. Electric potential is synonymous to electromotive force, or this is EMF, electromotive force. Or this is also known as the electron moving force. No? Electron moving force. Okay. The electrical force that moves the charged particles, such as electrons, expressed in volts. Okay? So that is the definition of an electromotive force. It is synonymous to voltage. Voltage. We have the formula here, no? Volts. The volts is a unit of potential difference. We have the equation here. I just hope you see this. Okay. Okay. Our V is equal to our E over Q. What is E? That is energy. Energy. We may replace our energy by W because energy is synonymous to work. Parehas lang yon. They're just the same. Energy is synonymous to the work. Work, energy, just the same. So this is, you may replace this as W over Q. Meaning that is the work done per unit of charge. That is the voltage. Work done per unit of charge. Voltage. A potential of 1 volt has a capacity to do 1 joule. A joule is a unit of work or energy. No? A potential of 1 volt has a capacity to do 1 joule of work in moving 1 coulomb of charge. Later, I will discuss to you what is coulomb of charge. What is coulomb? Okay? If there is 1 coulomb of charge, imagine a coulomb of charge. It has so many electrons, a coulomb of charge. So, 1 joule per coulomb. Joule per coulomb, that is volt. No? Joules per coulomb, that is volts. Okay? So, let's go over here. Voltage. What does a volt mean? We know more voltage means more electrons can flow. Okay? More voltage means more electrons can flow. Because they are directly proportional. They are directly proportional. Volt is joules per coulomb. We said this earlier. Work per group of flowing electron. So, there are group of electron known as the coulomb. Okay? So, there is a battery here. There is a tester here. By the way, next meeting, this is my promise to everybody. I will, circuit, I will teach you how to practical. This is a practical discussion. I have my multimeter. I will teach you how to use the multimeter. Give me around 15 to 20 minutes to teach you this, no, or less than 30 minutes. Because I found out when we conduct some training, no, there are already some, there are just some, already an engineer do not know how to use the multimeter. I'm quite sad as a teacher. No, I want to help those engineers or student, no? Or maybe just forget the usage of that tester. But you should not forget the using the tester. Just like a doctor, this is our stethoscope. Do not forget this. You know, when you learn driving, if you are a driver, you are always a driver. You will never forget that. I remember I did not drive for around 4 to 5 years. But when I back driving after 5 years, no, I find it easy. It's not hard to recall my learning on how to drive. It should be the case when using the tester. Okay, engineer, will you test the voltage here? Will you measure the voltage? Talk. What happened to the tester is talk. What happened? He's already an engineer. He measured the voltage with his tester is in ohms. I remember he is and he was enrolled to our building wiring class. We are on actual. Will you measure the voltage here in the outlet? I heard a tick, tick-tock, tick-tock, tick. No? Narinig ko. The meter breaks. Buti na lang, fuse lang ang nasira. No? When we open the multimeter, the fuse blows. No? The fuse. Okay. So, we have here, no? A tester, we have a battery. So, a 9 volts battery can do 9 joules of work or heat per Coulomb. Okay? So, if we have a 9 volts battery, we'll be having here 9 joules of work. 9 joules of work or heat. Okay? Per Coulomb. No? In 1 Coulomb, there are 9 joules of work. 9 joules per 1 Coulomb is 9 volts. Always remember that. Okay? Please listen carefully to our Filipino audience or everybody. I say Filipino audience because this is also fits your learning, not only in your college classes, but also for the licensure exam. No? Okay. So we have the voltage. Think of the voltage like a pressure in water pipe. When you open the faucet, no, then you introduce now the voltage. No? The more voltage means more pressure. No? If we increase now the bulb, no, more water would flow to the conduit or to the pipe, no, or to the hose. No? More voltage once you adjust your faucet. More pressure means more water can flow. More voltage means more electrons can flow. Okay? You see here, his word is more electrons can flow. He used the word electrons can flow. More electrons can flow. He did not say here, more current can flow. See? He did not say here, more current can flow. I think we are one in this, the author of this file. Huh? Okay. We are one. Basically, for the voltage source, let's say we have a piece of marble here. Huh? Inside the source, no? Or basically, the charge or the current. Okay. Let's go first for the current, although I said that is wrong. No? The current or the electron, let's put it this way first. The current will flow or the electrons will flow from negative to the positive. Try to imagine there is a marble here that represents the electron. So it flows from negative to the positive. Let's go over with the electric current. Any directional movement of electric charge such as electrons. So there is a movement of electric charge. No? Who moves? the charge. The charge moves, no? Any directional movement of electric charge such as electrons. Electric current is expressed in terms of ampere. Well, this is just one definition of current, but this is not actually the definition of so many books. I think I don't have here, but you may verify this to so many books. That the current is equal to the charge per unit of time. Okay? The charge per unit of time. For example, we have a 20 ampere circuit breaker. Meaning, there are 20 Coulomb of charge flows. 20 Coulomb per second flows. So, 20 ampere means 20 Coulomb per second because current is the charge per unit of time. This is actually the rate of flow. If we are talking, if that is with respect to time, meaning you're talking of the rate. What is your rate when you are driving your car? I'm driving 200 kilometers per hour. Wow. No? My friend would say, the policeman, ano yun, nahuli siya? Caught me. No? There is, in the highway, the policeman has a motor vehicle. No? The policeman said that, I'm arresting you. Why, sir? Because I am overspeeding 180 kilometers per hour. I am overspeeding. No, you are not overspeeding. Why, sir? Because you are low flying. Huh? When you drive a car, you're too fast. You feel that you are flying already. No? Yung mga driver dyan, maintindihan nyo ibig ko sabihin. No? Pag sobrang bilis mo, kala mo, hindi ka na lumalapag sa lupa. Ganun yun. So, if we have 20 ampere, 20 Coulomb per second. Meaning, if we are considering the equation with respect to time. Meaning, that is a rate. If the equation has a denominator of time or per second, that is a rate. The exact definition of current is this. Current, that is the rate of flow. Rate of flow of charge. That is the rate of flow of charge. Remember, if we have here time, we are talking here of the rate. 20 Coulomb per second, that is the rate. No? Well, that answers. That's why I don't believe with the word current flow. Why? Because the one flowing is not actually the one flowing, I mean. Because current is just the rate of flow. Rate of flow. The one flowing actually is the Coulomb. No, it's the Coulomb. Let's go over here. There you are. Oh, I have here in my PowerPoint. Nauna na ako sa kanya. Current is 1 ampere. Current of 1 ampere is equal to 1 Coulomb of charge flows a given point in 1 second. See here? I is Q over T. The one flowing is actually the charge. It's actually the charge. With no current applied, the free electrons within the copper atom will move randomly between other atoms. If there is with no current applied, with no current applied, it should be with no voltage applied. The free electron, actually, we already studied that. The flow of electricity is the flow of free electrons, no? within the copper atom will move randomly. Let's say there is a free electron here. This will just move randomly. No? With current applied or voltage applied. I think this is, it's better to say with voltage applied, the free electrons within the copper atom will move in the same direction between other atoms. So let's say for the battery, no? So we have here, no? Current flowing here. See? This one. Take a look here. I will discuss to you the flow of electricity. The flow of current. It's better to say the charge flow or electron flow. Remember that. For me, the word current flow, the current flowing in a circuit, for me, this is wrong. But of course, we just have to use it because that is being used all over the world conventionally. Right? Pero mali eh. Mali eh. It's better to use charge flow or electron flow. No? Charge or electron. To be specific, free electron flow. Free electron flow. It's better. That is more specific way of saying it. The charge flowing, that's better. The free electrons flowing, okay? That's great because that is most specific. The one really flowing is the free electrons. It's not current. The charge is actually flowing. When you divide the charge to the rate or the time, when it transfer from one point to the other, let's say, you have to divide by time. Let's say you have 100 Coulomb. No? A certain charge travels from point A to point B here. So this is 100 Coulomb of charge. It took 2 seconds to travel here. So you have to divide 100 divided by 2 seconds. So you will come up with 50 Coulomb per second because that is the rate. That is the rate. That is not the one flowing. Naintindihan niyo ba ako? Galit kaya yata, sir, Hindi. Are you getting me, guys? Makaka-aware pa? Nakukuha ba ako?
Sir.
Yes, sir.
Aris ba ay naintindihan ako? Naintindihan ba ako ni Aris? Si Sir Garcia. Sir Garcia, do you understand me? Did you get my point? Okay. Well, of course, I can't do nothing. I am just one. No? I can do nothing. No? So we have to use this conventionally. You know, if we mean conventional, sometimes it's not correct. It's wrong. I'll show you another wrong. So, we have here a light bulb or incandescent bulb. Okay. Let us put a circuit here. There is a switch here. Let us put a circuit breaker. Okay, may circuit breaker tayo. Oh, this is a complete electric circuit. There is a voltage, resistance here, no? There is a conductor, there is switch, there is protection. That's complete the circuit, no? Okay. Remember that this is positive, this is negative. Okay. Let us go over to the direction of current here. We in engineering in our country, in the Philippines, maybe in other countries also, we are using this flow. If we are considering the positive terminal of the battery, okay, then it will go to the negative terminal. But you know, this is the conventional flow of electron. conventional. Just say, class, conventional flow. Conventional flow of electron. Conventional is somehow similar to traditional. That is already a tradition. But actually, that is wrong. That is not the real flow of electricity. Take a look again. We are using this because even in electronics, there is a diode here for you to know, just like I teach yesterday, they have the same, that is forward bias. If the current flows to the left, that is a reverse bias, the diode. That is a conventional way. Because in electronics, it's easier to analyze the circuit if we are using the conventional way. But actually, that is not the real. That is not the truth. Okay? What is the truth, sir? The truth is this. Actually, I already discussed to you that one. From negative to positive. That is the truth. And nothing but the truth. Okay. So, that is what we call the real flow of electrons. Alam nyo, lumabas to sa board exam. It came up to be a licensure exam question in our country, in the Philippines. What is the question? The question is, what is the conventional flow of electron? Okay? What is the conventional flow of electron? That is the question in the licensure exam. So, we are lucky that our licensure exam is multiple choice, A, B, C, D. Okay. There is so many choices. So that's too long. Okay, I will answer it directly so that I can discuss many things. What is the conventional flow of electron? What is the conventional flow? Okay, this is the answer. This is the conventional flow, the red one. You see? You see the red one? Because in these choices, there are words internally and externally with respect to the source. Internally and externally with respect to the source. Conventional flow, looking at the conventional flow. Conventional flow externally, no? Externally, the conventional flow is from positive. Take a look here. Yung nasa labas niya, externally, okay, outside of the battery, okay, externally, the conventional flow is from positive to negative. Positive to negative. Okay? But internally, that is negative to positive. You see? You see? This one, that is a conventional flow in a clockwise direction. This is conventional. Inside of the battery, that is negative going to the positive. But externally, it is positive to negative. Are you getting me, Billy? Where is Billy? I don't see Billy anymore. Billy, are you listening there?
Yes, sir. Natawag lang.
Okay. Okay. Again, conventional flow is from positive to negative externally, but negative to positive internally with respect to the voltage source. Now, let us go to the real flow because this is the truth. This is the true flow of charge or free electron. The real flow externally, the blue one, externally, the real flow moves on a counterclockwise. Isn't it? That is counterclockwise direction here. Externally, it moves from negative going to the positive of the battery. That is externally. From negative to positive of the battery. But internally, no? In the inner part of the battery, it moves what? From positive to negative. Okay, well anyway, the only question in the board examination is just the conventional flow. It's just the conventional flow. That is the only question. What is the conventional flow of electron? Internally, externally, with respect to the battery? Again, conventional flow, it flows from positive to negative externally. But internally, that is negative to positive. And then they just rambled those words, no? Put it in here, okay? So, that's already a board exam question. Well, this is the difference with my discussion with your professors. Because me, I will discuss the past and possible board exam or licensure exam questions. This is the big difference of this discussion. So, if I were you, I will not miss this restudy electrical engineering. No? So many things to discuss. Okay, let's go over here. Current is the flow of electrons measured in amperes, a past single point in a circuit within a set amount of time. 1 ampere is 1 coulomb per second actually. What is 1 coulomb? 1 coulomb is, well, it's quite confusing that I'm reading some book, no? When I study, I don't focus only on one reference book. When I was a student, I don't focus only on one book. I'll try at least 3 books. I will borrow it in our library because during those times, no, there is no Google. No, there's no internet during my time when I was in college. That was in 90s. So, this is 1. This is 6.24, no? How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But you will have here 6.242. Okay. 1 coulomb, we show it here. 1 coulomb of charge. I'll put it here. 1 coulomb. There are books that says this. 6.24 times 10 to the 18 electrons. These are free electrons. That is 1 coulomb. Coul is coulomb, no? Okay? They got this name from the name of a scientist named Charles Coulomb. Okay? Charles Coulomb. Okay. Now, please take a look. Please take a look. 1 coulomb, 6.24. The other book would say 6.25 times 10 to the 18 electron. Then, I saw another book that is 6.28 times 10 to the 18 electron. Which of which, sir? I don't know. Because that is just found on the book. But what I can say is, you have to verify to so many references. Majority wins, I mean. If I'll be the one to take the licensure exam nowadays, I will use this. Because I saw some review materials that indicated 6.25, no? And then there is an actual licensure exam or board exam question. Let's go over here. I will use the 6.25 times 10 to the 18 electrons. What is 6.25? 6.25. How many zeros do we have? How many zeros? So, let us move the decimal 18 times going to the right. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is the decimal point. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There are 16 zeros. That's too many. That is only for 1 coulomb of charge. No? Let's go over here. Electrons are negatively charged. They flow from the negative terminal to the positive terminal. You see? They flow from negative terminal. They flow from negative. He said here as electrons are negatively charged. They flow, meaning electron that flows. It is really the electron flowing, not the current. Electron flows are negatively charged. From the negative, this is the negative charge, to the positive terminal. Meaning that is externally. This is the negative charge going to the positive terminal. Okay? So negative going to the positive terminal. You see? Let's say there is an electron here. Let's go over with resistance. What is resistance? Resistance is the property of a material to oppose or limit the flow of current or the charge. No? So, it opposes the flow of charge. No? That is the resistance. I will have a practical example. Take a look here. Please focus here on the eraser. Let's say this is the charge. This is the charge. Okay? Or the free electron. These are group of free electrons. I will push it here from left to the right. Okay. The force on my finger is the voltage. That is the pressure. That is the force being applied to the charge. That is the voltage. Then this flows. This charge flows. Okay? Then it flows. Let's say we have 2 coulomb. Then it transfers from this point up to this point for 2 seconds. 2 coulomb for 2 seconds. 2 divided by 2. So we have 1 coulomb per second. So therefore, there is 1 ampere. There is 1 ampere. This is 2 coulomb. It took me 2 seconds. 1, 2. 2 coulomb divided by 2 seconds. So we have 2 amperes. So that is the current. Again, it's better to say charge flow or electron flow. Question. Look at this. Where is the resistance? Where is the resistance? Everybody. Where is the resistance here?
At the rail, sir.
Friction.
Where?
Friction.
Yes, very good. Marlo Aquino. That is the friction. What is a friction? From physics or engineering mechanics, if you apply to a block, if there is a block here, you apply a force, there is an opposite force, no? There is an equal and opposite force. That is what we call the law of interaction, no? That is the law of interaction of Newton's law, no? Newton's law of interaction. There is external force F or force P, and there is a frictional force. Equal and opposite in direction. That is the resistance. That represents the resistance, the frictional force. The resistance oppose or limit the flow of current or charge. You see, I said the flow of current is wrong. Di bale, bumawi naman, or charge. Okay? So, let's go over here with our formula. Resistance due to dimension. No? Where, take a look at the formula. So, we have the Greek alphabet. R is equal to rho L over A. Where R is the resistance in ohms. Rho, no, this is Greek alphabet rho. No, you know Greek? Greek. What do you mean by Greek? Greek alphabet. That is being used in the country of, who's that NBA player? Giannis Antetokounmpo. Did I pronounce it correctly? By Giannis. No? This is Greek alphabet rho. Rho. R-H-O. Rho. That means resistivity in ohm centimeter or ohm meter. L is the length in centimeter or meter. A is the cross-sectional area in square centimeter or meter. Let us study this formula. R is equal to rho L over A. Just like what I've told you before, what I teach you before. Teach you or taught you before? What's the correct grammar? I'm sorry. Okay, so, take a look here. What is the relation of the resistance to the length? Let us have the relationship. Resistance to the length. We will establish relationship of resistance to the area also. Take a look at the equation. Please take a look. Do you hear me clearly, everybody?
Yes.
Yes, sir.
What is the relationship of the resistance to the length?
Directly.
Directly or inversely proportional? Directly or inversely?
Directly proportional.
Okay, so will you answer, Eunice?
Directly proportional to your...
Taas pa yung paa. Ang sarap kumain yan, no? May sinangag tsaka tuyo, di ba? Tsaka meron kang champurado. Okay, what is this, Eunice?
Directly proportional.
Directly. Why is it directly proportional? Okay, why they are directly proportional? Why?
Position at the
Is why this is directly proportional? Why? Okay. Because, okay, I think his signal was cut off. Okay. So, because it is found on the numerator. It's found here.
Yes, sir. Same level lang sa nasa numerator.
Yes. There is a board exam question. As the length of the wire increases, umahaba, it was lengthened. As the length of the wire increases, the resistance blank. That is a licensure exam. Letter A increases also. Letter B decreases. Letter C remains the same. And letter D, none of this. So what is the answer?
Increase.
They are directly proportional, no? If we increase the length, let's say this is your conductor. If we increase the length here, okay? So, the resistance will increase. Let's say this is the first condition, R1, this is R2. So, therefore, R2 will be greater than R1. With the same size. With the same size of conductor. This is longer. The longer conductor has the bigger or the higher resistance. Okay? The longer conductor has the higher resistance. Now, what about here? They are inversely proportional. Is that correct? Oh, that's wrong. Okay. The resistance is inversely proportional to the area. Why? Because that is on the denominator. Nasa ilalim siya. As we increase the area, no? As we increase the area, okay, the resistance decreases. Remember that. This is a very good example. Take a look. From this size of conductor, we will make it larger conductor. Shall we say this is a conductor that is, what about? Let's say this is 2.0 square millimeter. 2.0, this is 3.5 square millimeter, huh? This is 5.5 What else? What's the next size? 8.0. This is 14. So from 2.0 square millimeter size of the building wire going to the number to the 14 square millimeter, that is around 1, 2, 3, 4 steps higher. 4 steps higher. So meaning, as we increase the area, the conductor becomes larger. What happened to the resistance? It decreases. Dito muna tayo. Let's go first here. Because this principle is being used by many electrical designer. They tend to oversize the wire. The electrician would say, engineer, no? Your wire size is too large. Will you decrease that? No, I will not decrease that. Because there is a reason behind. That is why I am increasing the size of wire. Because I learned that before when I was working. No? There are so many reasons. I will discuss to you on the next topic. No? Why is that it's better to oversize the wire? A bigger wire is more expensive. But many electrical designers prefer to use a larger size of wire. I'll give you one reason here. Actually, I listed around 7 reasons, but I will just discuss to you only one reason. Because that is too long to explain, no, everything. Okay? Once we go to DC circuits, I will explain that further. So, why is that they oversize the conductor? As you see here, this is a basic principle. Again, as we increase the area, the resistance decreases. We increase the area from 2.0 to number 14. The resistance decreases. Huh? You see, take a look here. There is a source here. And then, there is the resistance of the line. There is a load here. Okay. There is a current flowing here. So this is our voltage source. This is our load voltage, the voltage here. Okay. This is our voltage source. Voltage source, the load voltage or the terminal voltage. And then we have here our current flowing in the circuit, continuous flowing. This is just a voltmeter. And then this is the resistance. Please take a look. Please take a look. There is a voltage here. No? Being consumed by the wire. These R represent the resistance of this wire. The whole wire here. Or conductor. Okay? What do you call this voltage? Because IR is voltage, right? That is what we call the voltage drop. That is the voltage drop. Let us have here, no? Vs is equal to VL plus V sub D. Take a look here. Our voltage drop, V sub D, is simply equal to IR. That is what we call the voltage drop. Okay? What is a voltage drop? For example, okay, big sun, I have a big sun and small sun. O kuya, okay son, will you give this to your younger brother? I will give you 100 pesos. I'll give you 100 bucks. Okay. But, your small brother received only 70 pesos or 70 bucks. My input, I gave to my older son. No? Okay? I gave him 100 pesos. But his small brother, I told him to give that 100 pesos to his small brother. Please give this 100 pesos to your brother. But, the youngest brother received only 70 pesos. Where is the 30 pesos? Where? Voltage drop. You see? Question. Where is the 30 pesos? Maybe on the pocket of the big brother. Okay? Where is the 30 pesos? Maybe it was lost. Did that 30 pesos that represents the voltage drop, did that receive by the younger brother? No. No is the answer. Absolutely not. What do I mean? Since I already gave example, the 100 and the 70, let's put it in here. Okay. We have Vs, 100 volts. That is equal to, the small brother received only 70. And this is now the voltage drop. The voltage drop, this is missing. How much is missing? From the equation, the voltage drop is 100. Let us transpose this one, minus 70. So the voltage drop is 30 volts. 30 volts. That is the voltage drop. From this equation, what is the formula for the voltage drop? The voltage drop simply equal to, take a look here, that will be your Bs minus your BL. Bs minus BL. You see? The source voltage minus the load voltage. That is the voltage drop. This is garbage. You know? The voltage drop is nothing. That must be reduced. But how to reduce the voltage drop? I have said that voltage drop is nothing. That is a garbage. That must be reduced. It's not totally eliminated. Okay. So, we have the voltage drop here, no? That is nothing. We have to reduce. How to reduce the voltage drop? Please listen carefully. I'm trying my best to explain it in a very detailed way so that your time will not be wasted. You can understand. Okay? How to reduce the voltage drop? This is one way of reducing the voltage drop. You increase the size of wire. Again. What is the voltage drop formula? That is the current multiplied by the resistance. Meaning, the voltage drop is directly proportional to the resistance of the wire. Okay? Now, take a look at the formula. R is equal to rho L over the area. As we increase, please focus here. As we increase the area, okay, what happened to resistance? It decreases. Voltage drop is equal to IR. The resistance decreases. What happened to voltage drop? It decreases. Did you get that? Did you get that, Marlo?
Yes, sir.
Are you getting me?
Sir.
Can you ride on? Nakasakay ka ba?
Yes, sir.
Nakasakay. Okay. Chelo, naintindihan niyo ba ako?
Sir, wait lang, may nasikaso
Okay,
lang po sa
okay,
school.
sige. Okay, we are on live on our YouTube. Okay. No problem. So, we have to increase. Everybody, I hope everybody is listening. Please listen carefully, please. May I request this? Okay. Increase the size of wire will reduce the voltage drop. No? We have to, that is the principle That's why our electrical designer tend to oversize the wire. You know, my boss, I saw a design that is 6 step higher. I just made here a 4 step higher. A 4 step higher. So we have 1, 2, 3, and 4. Okay? This is 4 step higher. 1, 2, 3, and 4. Okay? 4 step higher. Nilipat-lipat mo din. Nilipat-lipat mo yung audience. Gusto ko iba-iba yung nakikita ko. Lipat-lipat mo. Para na-monitor natin lahat sila. For our Filipino audience in the Zoom, so please open your video. No? Or else you cannot get your certificate. So please, that's one of our policy. Please open your video. Okay, so please bear with us. Okay. So please take a look again here. Again, increase the size of wire to reduce the voltage drop. That's very important. I remember when I conduct a lecture, my audience are group of electrical engineers, already licensed. No? Most of them are RMEs, registered master electrician, and registered electrical engineer. There is a question. I remember that engineer is an engineer of SM. Schumart, that is the biggest mall in our country. Their electrician dies. His boss is asking quite a tricky question. Ano ba nakamatay? Voltahe o kuryente? Have you heard of that question? No? That engineer, no, he said that, sir, my boss is asking me because our electrician dies. What make him die? Is it the voltage or the current? That's another trivia question. I think there are some students, Filipino electrical engineering students, asking me that because that is assignment of their professor. Which skills? Is it the voltage or current? Based from my discussion, what can you say? You know, the one that kills. Which the one that kills, no? Is it the voltage or the current, no? Namatay yung electrician niya na kuryente. His electrician was electrocuted. No? Which of which? The reason. Is it the voltage or current? Voltage or current? That is the question. This is my answer. This is my honest answer. The question is incorrect. That is my answer to the engineer. I'm giving a lecture with them, no, in front of the engineer, and he was shocked with my answer. Oh, sir, meron kasi mga kasama kong engineer. My fellow engineer are saying voltage, but there are some saying current. But you have a different answer. For me, that's wrong. That is a wrong question. That is a wrong question for me. Why? Again, what is a voltage? Show up here. A voltage is electron moving force. This is the parameter, electrical parameter. This is a voltage. This makes this charge flow. This makes this charge flow. This is the voltage. As we increase the voltage, the current increases also, based from Ohm's law. Are they of one kind? Are they of a kind? Are they of one kind? Or they are different parameter? First of all, are they the same or different? Marlo, what is your idea? Are they the same or different? This is the voltage, my hand, and this is the current. Are they different or just the same? Marlo?
Professor, they are different.
Okay, very good. They are different. What is my point here? You cannot compare two different things. Which, okay, I'm looking at this. You see? There you are. Let's go over here, Simba. You see Simba here? Do you know Simba? The Lion King. Okay, I have so many Simba here. You see? What is the name of the father of Simba again? Anak, anong pangalan tatay ni Simba? Because I watched The Lion King before. That's my favorite movie.
Mufasa.
Mufasa. And Scar, right? I don't have Scar here. I will assume that this is Scar, who look almost the same as Scar. This one. I should have a black lion. This is Mufasa, the father of Simba. Which is more handsome? Is it Mufasa or Scar? Which is more who is handsomer? Oh, my English is it's a by galiway. Okay. So, which is more handsome? Is it Mufasa or is it Scar? Can you compare the two? Yes, because they are both lions, right? They are both lions. You can compare two things if they have of the same kind. Who is handsome? Me or Scar?
Marriage.
Ha? Sip-sip. Tayo ganun eh. Na-joke lang ha. Baka hindi ka na umatin. Can you do that? Can you compare two different things? I am a human being and this is a lion. That's nonsense. Are you getting me? Are you getting me?
Yes, sir.
I'm wondering if your college professors teach like this one. I'm wondering. No? As deep as this one. No? Because this is how I teach in the university. This is how I teach. In my school, I've been teaching for more than 20 years. This is how I teach. I'm not new. I'm just new because of the Zoom here and YouTube, but this is the way I teach in the classroom. I don't change my style. Maybe I just have to speak here in English. That is something new to me. I have to speak more English. English pa more. Okay. You cannot compare two different things. Always remember that. Always remember that. Never compare two different things. That's why it is a wrong question. That is a stupid question. That is a question of a layman. You're an electrical engineer. You should know how to distinguish. No? That's stupid question. No? Hindi magandang tanong yun. Maling tanong yun. Okay. Okay, I will have an example. Our president, for me, our best president of all time, President Rodrigo Duterte. I think he is also known all over the world. Huh? Because of the war on drugs. President Duterte said, okay, I will build this building for you, for my poor Filipino fellow men. I will build this building for you. For poor Filipino who are living under the bridge, who are living near the Smoky Mountain, the government will help you. I will build this building. Question, who built this building? Who actually built this building? Is it our president, Tatay D, or the construction worker itself?
Construction worker.
By the way, if your answer is the construction worker, but how they did that? Of course, there is a force. There should be a force for them to move or to work so that they can build that building for the poor. Who built that? The president? Is our president the one making the electrician work? No? You know, is he the one mixing up the cement? No? Making the chipping works? Is he the one? Of course not. The contractor just need the signature of the president. And that is a very powerful thing to do by the president. You cannot compare. For me, that is a stupid question. If your professor is asking that, that is quite stupidity for me. Manapa, alam nyo, mas tama para sa akin, both na lang ang isagot eh. Oh, sir, both. Baka mas tama pa yun eh. Pero kung isa lang, okay, who will answer voltage only? And who will answer current only? I will answer both of you. Okay. Who kills? Is it the current or the voltage? Sir, the current, because the current is the one flowing, going to his heart. No? It's the current. But, first, wait. Why current flows? Is it because of the voltage, right? That's because of the voltage. I think if I am your professor, if you will answer both, it's better. It's better. But do not answer one only. That's wrong. Because current without a voltage, no, is nothing. No? It's nothing. Well, that is my opinion. It's up to you if you will believe or not. That is just my opinion. Just like before. Current flow, charge flow, it's up to you if you will believe with me. No? But that is my deepest and honest from the bottom of my heart answer. See? No? Kita nyo? Buti pa, both na lang eh. Voltahe, tsaka kuryente, nakamatay. Hindi po pwedeng wala yung isa doon. There should be a presence of the voltage and the current. There should be two. That is a wrong question. I never do that to my student. It's better to give a take-home exam. Why is that the bird don't get electrocuted? I'll give you my answer later. Okay. Are you getting me? Marlo? Nakukuha ba? Nakikinig ka pa, Marlo, dyan?
Loud and clear.
Are you enjoying listening? We're not yet finished.
Yes, sir.
Just on my halfway. Is it okay to you? I will discuss up to 2 p.m.
Yes, sir.
Okay. I'm sorry, I cannot. Okay. So with this, continue this next meeting. But I will just finish what's on the PowerPoint here. Okay, let's continue our discussion. Okay, what about the resistivity? Take a look at our formula, guys, no? So, please take a look here. So, this is our rho. Our rho is the resistivity in ohm meter, no? It is the resistance offered to a current if passed between opposite faces of a unit cube. of the material. It is measured in ohm meter. Again, it is the resistance offered to a current if passed between two opposite faces of a cube. So if we have a cube, no, we have the two opposite faces of a cube. I'm looking at a cube if I have here. I saw this one. Okay. So resistance offered, no, to a current if passed between the opposite faces. So this is a cube. You see? Nakikita ba yung pagka-cube niya? This is a cube. So I will, there is a resistance here. It is the resistance offered to a current if passed between opposite faces. If the current flows from this point up to this point, no, of a cube of a material, that is the resistivity. No? There is a resistance here. That's why it is called a resistivity. It is the measured in ohm meter. There are the factors affecting resistance. We will do this calculation starting next meeting, no? Okay? So our next meeting actually, no, it will be this coming tomorrow we have a special a webinar, pre-webinar. Bali ano na pala tayo on Friday na pala, no? So on Friday our next class for the restudy. But tomorrow we still have a pre-webinar, no, entitled electrical estimation. Now, but that is in Tagalog, no? Okay. So, we have these factors affecting resistance. Nature of material. Okay? The nature of material indicated in the resistivity. Every material has different resistivity. Then the length of the material. The length of the material, okay? Everybody please listen, no? The length of the material, no? And the cross-sectional area. This is the cross-sectional area. Okay. If we are to get our resistance, that is rho, this is the resistivity, L squared over the volume. The V is the volume of the material. Then R is the rho V over A squared. No? So, I'll show you some calculation next meeting. No? Okay, let's take a look at the resistance. No? Let's say we have a copper conductor here. We have an iron conductor. You will see here that let's say for copper, the electrons, it can flow easily, no, compared to the iron, no? Okay? It bumps here in the atoms of the iron, no? So meaning the iron has a higher resistance compared to the copper, no? Okay, resistor protects component by restricting the flow of current. So we have here the resistor. There is a current flowing here. Okay? So too much current. That is why if you install, this is an LED, light emitting bulb, no? It is required, no? Electronically speaking, it is required to put a carbon composition resistor here. I'll discuss this later. No? If you have an LED here, it is required. Usually it is required to an electronic circuit that you have this resistor. Why? Because if you don't have this resistor, this may burn out, no? Okay, masusunog ito. That will blows. No, so it will become a dead, no? Too much current will flow. That is the importance of the resistance. It limits the flow of current. Okay. We have the root, electrons can flow along. We have the LED, we have a closed circuit here. Okay. Then let's say what happened if the switch is open? Of course, no, this will not light up. No, that will turn off. Take a look here. Resistance is a restriction to the flow of electrons. Okay, the longer wire, okay, more resistance. The thicker wire or the larger wire, it has a less resistance. I discussed this already with you. The larger wire has lower resistance. That is why lower voltage drop. Okay? Voltage drop is a garbage. That's nothing. That must be minimized. Okay? So, material. If you have a copper that has a less resistance, no, than aluminum, no? More resistance ang aluminum, no? So temperature, we'll discuss this next meeting, no? As the temperature increases, you see there is fire here, there are more resistance. As the temperature increases, the resistance also increases. Let's go back here. The copper has a less resistance compared to the aluminum. I'll prove that to you. This is one of the table from the Philippine Electrical Code. Even in National Electrical Code or any code, you may see this for our non-Filipino audience, to our friends. Okay. To our, how we call them? To our kawerpa foreign friends, no? To our kawerpa. Okay. So, take a look here. Will you focus this one, please? Focus. We have an 8.0 square millimeter. Let's say we have a TW copper conductor. What is the ampacity? Ampacity is the current carrying capacity of the wire. Okay? That is the capacity of the wire to carry the current. Okay? So, 8.0, we have ampacity of 40 amperes. 40 ampere may flow through it. Okay? That is the capacity or the ampacity of a copper conductor. It is copper. Let's go over with aluminum or copper-clad aluminum. Let's go over here. Of the same size, for copper, we have 40 ampere. But, let's go over with aluminum. For the same size, 8.0, the ampacity is 30. You see here, did you see 30? Please focus this. Anak, okay, close up mo tong 30. You will see in the table of the same size, 8.0 square millimeter, for copper, 40 ampere. For aluminum, 30 ampere. So meaning of the same size, parehas lang ang size nila, ibang material, no? Mas mababa, no? The ampacity of the aluminum is lower compared to the ampacity of the copper of the same size. Are you getting me? Norberto, nato ka na yata dyan, ha? O picture yan? Okay. Sige. Everybody, please listen, ha? I'm watching you, okay? From a distance, okay? So, please, my student in the Zoom class, please listen carefully. Are you listening? Are you listening?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes,
Thank
sir.
you, thank you. Okay, let's go over again electric circuit. Okay, so let's go over with the conductance. What is conductance? It is the measure of the ease. Meaning there is ease, no? Madali. There is an ease with which electric current will flow through a material. It is the reciprocal of resistance. We have Siemens. It is the unit of conductance named after two German engineers, Werner and William Siemens, 90th century. No? So, well, this is also a name of a company, no? Siemens. So, we have the G that's equal to 1 over R. So, our G, that is it symbolizes the conductance. No? That is the reciprocal, 1 over. No? So, our G here, we have this symbol, lowercase sigma, a Greek alphabet. Conductivity of the material is the lowercase sigma multiplied by area divided by the length. Let's go over here. G is 1 over R. G is equal to 1 over R. So, 1 over R, okay, the unit of resistance is ohm. The unit of G is mho. Mho or Siemens. Mho or Siemens or Siemens, how you pronounce it. Okay. Mho. Meaning you just reverse the resistance ohm. Ohm. You see ohm. Ohm. You reverse this one. Mho. Mho. Okay? What is the unit of capacitance? Farad. 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 Capacitance. There is opposite of capacitance known as elastance, 1 over C. What is the unit of elastance? We'll take up this later, no? But what is the unit of elastance? Darab. 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 So you just reverse this. Farad by darab. I asked to my friend, why is that your son's name is Idrep? Your son's name is Idrep. 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 Where did you get that name? That's quite unique. Pare, ako din yun. My name is Ferdi. Okay? My name is Ferdi. No? That's why the name of his son is Idrep. No? Parang tayo lang yan. Power. Where pa? Di ba? Yorme. Di ba? So, parang tayo lang yan. Okay, ha? Are you still listening, guys? Nakaka-aware pa? Nakikinig pa ba kayo dyan?
Yes, sir.
Yes, sir.
Okay, let's go over with the carbon composition resistor being used in electronics. I will discuss this. Resistor color coding. So, we have the first digit. We see here the yellow one. The first digit, the yellow one. The second digit is the violet. We have a violet here. The third band, this is what we call the color band, no? Is the multiplier. First, second digit, the third band is what we call the multiplier. And the fourth band is what we call the tolerance, which is color gold. We will find the value of this carbon composition resistor. Take a look. I know you're familiar with this, no? Okay? But we have an audience who are zero knowledge, no? They are high school graduate, no? Or senior high school graduate, no? For our electrical engineering students or graduates, this is a review for you. Because this is being asked also in the licensure exam. For our foreign friends, no? So, for non-Filipino audience, this is a learning for you, for everybody, for all of us, no? So, good day to all of you. No, we are not yet finished. Okay. So, let us get the value of my example there, no? What is, okay, again, we have the first digit is yellow. Yellow. Put here Y. Yellow. The second digit is violet. Violet. The third is the multiplier. That is the red. The red. And then we have a gold. The fourth band or color. Let's go over to our CCR table. Why is it called the CCR or CCRT? What is CCRT? Carbon Composition Resistor Table. Okay. The first column is the color. The second is the first digit. And the second is the second digit. No? Okay, this is the third column actually. The fourth column is what we call the multiplier. And the last column here is what we call the tolerance. The tolerance. Okay, let us answer the question here. For color yellow, what is the digit for color yellow? What is the digit? For yellow, we have 4. We have 4. Okay? 4. So, put here 4. 4V. Take a look here. 4V, that is violet. What number? Here. 7. Okay, 7. No? 7. Okay? What is the third band? No? The multiplier, which is red. Where is red? Here. Please take a look. Please focus here. The red is 10 raised to 2. 10 raised to 2. So, meaning that is times 10 raised to 2. Okay? So, we have the gold. What is the tolerance for gold? We have here. Tingin ka dito. This is the gold. This one. plus minus 5%. Okay. So we have here plus minus 5%. Okay. So this is the gold, which is plus or minus 5%. What is the actual value of this carbon composition resistor? Let us get.
4.7 kilo ohm.
Actually, there is a range value. No? This is 47. No? We have here 10 to the 2, so we have here 0, 0. Put here 2 zeros here. Because of 10 to the 2. The 2 here. So we have here plus or minus 5%. We have the upper and the lower limit value.
Yes.
But how to do it? There is a 5% here. So 1.05, no? Because of the 5%, that is 0.05. That is multiplied by 47 hundredths. There. Huh? What about now, sir, the minus 5%? Okay, 1 minus 5% is what? 0.95. This will become 0.95 already because 1 minus 0.05, that is 0.95, right? Okay, then that is multiplied by 47 hundredths because you have here 10 to the 2, no? Okay, we get here 4,700 ohms. This should be a range, no? The value. Okay, 47 hundredths, no? Times 0.95.
4935.
4465. Again, 0.95 times 47 hundredths.
446.
Oh, tama, 4465, di ba? What about our 1.05?
4935.
4935.
1.05 times 47 hundredths.
4935.
4935.
35. So, the 0.95, no, times 47 hundredths, we have here 4465 here, meaning this is the range of the resistance within this range. Okay, misa sa katagalan ng gamit, no, pwedeng bumababa yung resistance niya, no? Okay? You see, this is the resistance range of the carbon composition resistor, no? It's not a fixed value. It may vary, no? Okay, so take a look here. As I've said before, the current will flow from the negative terminal to the positive terminal. Again, what is that flow? Real flow. From externally, from negative, going to the positive, that is the real flow of electrons. Now, there you are. So you will see here an incandescent bulb. If you are to take away this and you short the two terminal, what will happen? A large amount of current will flow. Large amount, no? There is what we call a short circuit. Short circuit basically is a zero resistance that will be indicated in your tester, or minimum resistance. That is dangerous. Actually, that is the most dangerous thing that will happen electrically, no? The short circuit. Okay? That is why our building, no? That is according to the Bureau of Fire Protection, no? The number one cause of fire is electrical. And if that is electrical, many would say that if there are short circuit, there are short circuit. There will be fire. Okay? Let us prevent this to happen. See to it, no? That our plug is always in contact properly. The conductor of the plug, I mean. Okay? that they should be intact, no? The plug. Okay? So I have a plug here. It's very important. You have a plug here. Especially there are some extension cord that has a plug that is loose. No? This portion, the metal portion, is loose with the rubber portion. So that should not happen. There are plugs that when you plug it in the outlet, then if you pull this one up, pull this one, no, the metal part is still on the outlet. You're just getting the rubber portion. Okay? When you pull a plug, see to it that you will pull it properly. Do not pull like this is on the outlet. Do not pull like this way. This way. Do not pull like that. No. I will have a pre-webinar on electrical safety. I will have a series of pre-webinar on safety. It's very important. No? You're an electrical engineer. No? You're afraid of pulling this extension cord? Oh, come on. You're an electrical engineer. No? You handle it that way. Put your hand here on the head of the plug. That is an insulator. Okay? You pull this one. Do not pull like this one. No. There is a connection here that will break down. And sometimes, that causes also short circuit. If you pull the plug like that one. Takot na takot ka. Don't be afraid. You handle that one. Higpitan mo ang pagkakahawak, tsaka mo tanggalin. Okay? Are you getting me?
Yes, sir.
Okay. So, when short circuit occurs, what happened? That is why, in the electric circuit, the component protection is very important against short circuit. One of that is our fuses. What will happen to our fuses? The fuse link now will become open. No? To open the circuit for the safety. No? Okay? Well, that's it for today. No? Thank you. Salamat po sa inyo. That's the end of my lecture. Are there any question? Okay? Any question? Anybody would like to ask question?
About the word zap.
Ha? Ano yan, Marlo? Marlo, did you learn the first, if you will, if you may, no? Can you give some comment about our lecture for today? Did you learn something, Marlo?
Yes, sir.
What did you learn? Even though I only discuss Ohm's law for more than 2 hours. Very long Ohm's law in the YouTube. Huh? Do you think, is it worth it viewing that 2 hours Ohm's law only
Yes, sir.
on the YouTube? Why? Why is it worth it?
You will learn many things about electrical.
Okay. Are you converting like me?
Yes, sir.
Still converting. Is that buffering?
Yes, sir.
Okay, buffering. Okay. Okay, ha? Okay. In Tagalog, we call this as lutang. Okay, ha? Maraming lutang, ha? Oh. So, any more question? Billy? Hello, Billy? Do we have Billy there? May ginagawa si Billy. Si Eunice ba? Si Eunice nga, tanungin ko si Eunice. Eunice, did you learn something?
Yes, sir.
Learn something new.
Informative, sir.
Did you learn something new?
Yes, sir. There are topics, sir, that were not discussed in our school.
Okay. Okay, since you are speaking in English, let's talk to each other. What are those ideas, no? You think that were not discussed in your school? Can you give me some example that some topics or some points, no, wherein that is quite new to you? Okay, Eunice? What are these? Something this point part of my discussion which is something new to you. What are these?
Sir, you
Ano 'yon? Speak in English. Nahiya siya. Are you ashamed?
sir, I'm sure.
What? Oh, dali, makikita ka sa YouTube, oh. Walang editing to. Hindi natin to na-edit. Sige na. Nag-English ka na kanina, diretsuhin mo na. Naambunan ka na eh. What is something new here? What did you discover something today? Something new. If you may recall. What? Maybe she's ashamed, no? Let's go over with the other student. May I see Sir Garcia? Sir Garcia, hello. Okay. He has a mask. Okay.
I've learned.
Sir Garcia, if you may, when you were studying your electrical engineering, did you learn something new here?
Yeah, sir. I have learned clearly how to compute the voltage drop.
Mahina. Will you speak louder, sir? You have a very thin line.
Yes, sir. I have learned clearly how to compute the voltage drop.
You learn how to compute the voltage drop. What else? Although that is just the most basic portion. No?
Yeah, yes, sir.
What else? Are you taking your notes there?
Yes, sir.
Ay, very good. Okay, that's nice. What else? What
you.
other? Yeah, very good. Okay, I'll check your notebook, huh? On finals. Because I'm doing it in my student. No, that's true. Oh, I was a former professor in my alma mater in UE, University of the East, Caloocan. I am checking the notebook of my student, no? Every finals, after before the final exam, they have to submit their notebook. What else? What else did you learn something new? Compare what?
The flow of the electrons.
The flow of the
To
electron.
the positive and then.
Okay.
Yes.
Sir, lumabas yan sa RME ha, yung flow of electron. Tinuro ko sa inyo yan.
I will talk to you separately, sir.
Okay, thank you, sir. Thank you. No? So, everybody, no? So, please put your attendance, no? Put your partner, no? Just put your name, no? Your name, your course, school. Your course, if you are a student, put your year, no? Your messenger name, your email address. Put it there before you leave, ha? Please don't forget. Okay, Billy, what did you learn something new today?
Sir, about yung voltage drop, yung sa resistance, sir.
Voltage drop, distance, okay. Do you have any question, Billy?
No, sir. It's all clear.
What did he say? Okay, it's all clear. Okay, what else? Joshua, may I know your comment? Or if you have any question, nawala si Joshua, tawag tayo ng ibang student. Kung okay lang kay Rina, is it okay with you to speak? Malayo yata yung kanyang cellphone. Aljonel, sige, si Aljonel ulit. Hello, Aljonel, are you listening?
Yes, sir.
Did you learn something new today or nothing?
I learned.
Do not attend to my webinar on the next day. So, I don't want to waste the time of any person, no? Whether you are a student or engineer, I don't want to waste your time, okay? Anybody. No? If you think you're not learning something new, you may not attend on the next day, no? Okay? So, did you learn something new? Arjun?
Yes, sir.
What is that?
About the internal and external flow of the electrons, sir.
Internal, external flow, what else?
I also recall the ano po, the values on getting the resistor values po.
Resistor values. Okay, is that something new to you?
No,
But do you have any question? Do you have any question?
none, sir. None, sir.
None. Okay, let's go over to other students. Sige, isa na lang. Gusto ko lang makakuha. Tingin tayo sa next slide. Ibang slide. Ibang ano. Ibang set of students naman. Baka sabihin yun at yun ang lagi kong tinatanong eh. Si Kim ba to? Kim ng PUP? Is that Kim? Kim, hello. Do you hear me?
Yes po, sir.
Okay. First, do you have any question, Kim?
None, sir.
None. Okay. How do you find the presentation for today?
I found it very informative po, sir. I learned many things.
Are you attending before? Since when?
Since July, sir, I think.
Since July. Did you learn something new in attending to our free webinars?
Yes, sir. Especially in calculator math techniques.
Okay. What about in electrical engineering so far? Do you learn something?
Yes, sir. Those things that are not taught in our school.
Okay, okay. Would you recommend us to your classmates?
Yes, sir. Some of them I've already invited them, sir.
Okay. Thank you. Thank you very much. No? Appreciated. Thank you. Appreciated. Okay, let's go over to other students. I'm very happy if I'm hearing some students are also happy because they're learning, especially something new. So I really appreciate those comments. It's a way for us to become more better, no? Better pa more. Okay. Sige nga, last na lang. Si Elmer ba to? Elmer Eugenio. Sir, pwede po bang makakuha ng ano lang sa inyo? Baka may tanong din kayo. Magtanong muna kayo, sir. Okay lang ba kayo, sir, magsalita? Okay lang. Makikita po kayo sa YouTube. You will be known all over the world. Where is Sir Elmer? Anak, ano mo si Elmer? Tawag dyan, ang tawag doon, spotlight. Will you spotlight, Sir Elmer? Sir Elmer, are you a student? Ay, mahina yung signal niya, naka-data. Okay, low bandwidth. Okay. Other student. One more student. No more? Okay, Joshua. I'll go back to you, Joshua. Ikaw lang ang nakikita ko eh. Ayan, yan na. Okay na si Sir Elmer. Sir Elmer na muna. Natawag na natin si Joshua. Yes, Sir Elmer.
Hello, sir.
Are you a student, sir? Or are you BSEE grad, electrician, or what? Technology?
Ano po, sir, yung first course ko, sir, BSIT Electronics.
Okay.
Sa Rigao State College of Technology.
Okay.
Tapos
Electronics.
nag-work ako, tapos nag-continue pa ako ng sir, yung Electrical Engineering Prof. sa University of Cebu. So, ano sir, yung
Nag-attend?
RE ko sir, ano lang yung ito sir.
Kung magets? You are undergraduate of electrical engineering? Or still studying?
Graduate po sir, graduate.
Ha?
Graduate po sir.
You're already graduate of
Graduate
BSEE?
po.
BSEE ba?
Yes sir.
BSEE.
BSE po sir.
Are you already a licensed REE? Not yet.
Ano lang po sir, yung RMA. RMA yung license ko, tapos bala ko mag-exam ngayong April for RA.
For the REE. You are already Master Electrician license. So, may I
Yes,
encourage
sir.
you to enroll with us, ha? So, I hope so. So, we have an early bird promo, no? For
Nag-enroll na po ako sir.
nag-enroll ka na pala. Okay, salamat. Yes. Yes, thank you, Elmer. No, you are already enrolled to Powerhouse. No, welcome to the Powerhouse family. Welcome. Okay, so that's it for today. No, to our friends. Thank you, Elmer. To our friends in our Facebook Live. No, thank you very much, everybody. No, and to our non-Filipino audience, thank you very much. No, we can still see each other again on Friday, no? This Friday, 9 a.m. Filipino time, Filipino schedule. Okay? Well, don't worry, no? So, because our lectures, no, is being uploaded in the YouTube. You may watch this anytime, anywhere you want, no? So, we encourage you to encourage your friends, no? Your friends, your classmate, your workmate. Please share our lecture video and always comment, no, on the comment section once you watch our videos, no. Di pa pala natin na-upload yung ano, no. Sige, mamaya i-upload namin sa YouTube the part 1 of electrical principles. This is actually part 2 of electrical principles. And next meeting, we are ready to go with direct current circuit, no. We'll make some discussion on these circuits, no. We have a very long discussion on DC circuit, especially the network theorems, the calculations, no? So many things to learn. So many things to learn. So I'm encouraging everybody to please encourage, please. Sana madagdagan naman kayo, please. No? Kakaunti, no? We want at least 99 Zoom audience. Okay? Or 100, no? Please encourage, no? Huwag ninyong ipagramot ito, no? Banggitin ninyo sa inyong mga kakilala, no? Okay? I-paste ninyo, send nyo yung link, no? Sa kanila. Okay, so yun na, mga nasa Zoom class, wait lang po, kausapin ko lang po kayo. Mag-out lang tayo sa Facebook natin. Sige, out. Maraming salamat po yung mga nasa Facebook live natin, no? Thank you very much, mga kawerpa.